Okay, so far we've gone through basic quadrilaterals, parallelograms, rectangles, rhombuses, and squares. Where we're going now, and I'm going to flip back to our beginning page of our chapter. Now we're moving left and right on our flowchart. We moved down the last few sections, and now we're moving over from a basic quadrilateral to this shape. And some of you already know this shape. It is called a trapezoid. And this shape, which some of you may have known but didn't know this is what it was, this is called a kite. Sometimes rhombus and kites get mixed up. And so we're going to go through a lot like we did in a parallelogram. We're going to go through the different properties. And then we're going to use those properties in a converse way or an opposite way to prove that this shape is a trapezoid and this shape is a kite. It's one thing to go through and say the shape that you're dealing with is a trapezoid, therefore all these properties exist. It's another thing to say, here's a property of a quadrilateral. What shape is it? And again, it's really important that you have all these properties written down because on a test, hint, hint, wink, wink, nudge, nudge, you might be told what shape has opposite sides parallel, opposite sides congruent, opposite angles congruent, but also has 90-degree angles and diagonals that are congruent. And you have to be able to say parallelogram, oh, rectangle. You won't be able to say rhombus or square, but you will need to name the most specific shape that has a list of characteristics. So let's talk today about trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So we know that in a parallelogram, both pairs of opposite sides are parallel. Trapezoids have one set of parallel sides. Theorem 814 says if a trapezoid is isosceles, then each pair of base angles is congruent. What that means is, here we have two parallel lines. We have congruent sides, and then just like in a isosceles triangle, if the sides are congruent, then the angles opposite those are congruent. If these two sides are congruent, then these two angles are congruent. That's what it means when it says base angles. It also says that if a trapezoid has a pair of congruent base angles, if these two angles are congruent, then it's an isosceles trapezoid where the sides are congruent. Theorem 816 says a trapezoid is isosceles if and only if its diagonals are congruent. Just like in a square and a rectangle, the diagonals of an isosceles trapezoid are congruent. This length and this length are congruent. No, they do not bisect each other. No, they are not perpendicular, but they are congruent in length. Very important that you understand that. So, keep going. Now let's actually use that idea of trapezoids to solve a couple of these trapezoid problems. In this first problem, we'll call it number 1. We're given this base angle of 53. It says to find the measure of angle B, angle C, and the measure of angle D. Well, we can still bring in our parallel line theorems. If this line and this line are parallel, and they're cut by a transversal, we have consecutive interior angles formed here. Consecutive interior angles are supplementary, which means that angle A plus angle B should equal 180. And so, if I subtract 53 from 180, I can solve for angle B, which ends up being 127 degrees. Everybody understand that? Good. Now, the next thing that we're dealing with is the isosceles part of this trapezoid. We can see that this side and this side are already congruent. Just like in an isosceles triangle, if the sides are congruent, then the angles opposite those sides are congruent. If these two sides are congruent, then the two base angles are congruent. Congruent means equal. So if this angle is 53, then this angle is 53. And just like what we just solved for angle B, we can use the exact same idea. If the top and the bottom lines are parallel, then we have these two sets of consecutive interior angles, and we can solve, using supplementary, that this angle is also 127. Now what you'll notice is, if these two angles are congruent, then these two angles have to be congruent. Hopefully that makes sense. In fact, I want you to go through and in this problem, we'll call it number 2, and this problem, we'll call it number 3. I'd like you to go through and solve for the missing angles, just the missing angles. Pause the video and do that now. Okay, so hopefully you had enough time to solve for the missing angles in number 2 and number 3. We still bring in the idea of parallel lines. We can see that in number 2, the top and the bottom line are parallel, and that they're cut by a transversal. And then they also tell us that this angle is 97 degrees. Well, we can see that we have, with parallel lines, we have consecutive interior angles, which should add up to 180. So I can say that angle A plus angle C equals 180. Well, if I substitute 97 in, I can solve for angle C just by subtraction, and I get 83 degrees. That's how I got my angle C. Then I knew that because this trapezoid is isosceles, that the two base angles are congruent. So if C is 83, then D is 83. That's how I solve for angle D. I then knew that on this side of the trapezoid, these two consecutive interior angles should still add up to 180. So if angle D is 83, then angle B would have to be 97. Not a whole lot of hard math there. I used the exact same ideas to solve for number 3. Found out that these two angles are supplementary, that these two angles were congruent, and that these two angles are supplementary. And so I kind of worked my way around clockwise. Hopefully that makes sense. Now let's flip the page and let's learn more about more about trapezoids. Here we have the mid-segment theorem. Now we've dealt with the mid-segment theorem with triangles before. The mid-segment theorem says that if you connect the midpoint of both sides, that you have half the distance of your base. This mid-segment is half the distance of your third side. Well, we're going to take that same idea, but we're going to apply it to a trapezoid. And what the trapezoid mid-segment theorem says, that if you connect 2 points on 2 sides, where this segment and this segment are congruent, this segment and this segment are congruent, you can say the top plus the bottom divided by 2, or times 1/2, gives you your mid-segment. It's just the idea that you're connecting almost two. It's basically like finding the average. It really is. Similarly, it's the exact same idea as the triangle mid-segment theorem. Not overly complicated, but something that you still need to understand. Theorem 818, again, this is where we're getting back into kites. If a quadrilateral is a kite, then its diagonals are perpendicular. The diagonals of a kite are perpendicular. Perpendicular, remember, means they intersect to form right angles. Much in the same way rhombus and squares do. In fact, if we go back to our very first page, we'll notice that a trapezoid is on the left-hand side by the rectangle. And the reason it's like that is because the trapezoid and the rectangle share the property that the diagonals are congruent. It's the only property they share, but they do share a property. Kite, you'll notice, is on the same side as a rhombus. The reason for that is kites and rhombi share the exact same characteristic, that the diagonals are perpendicular. Now that is the only property that they share, but they do share properties. So that's why the kite is over on the right and the trapezoid is on the left. If we go back to our notes, we find out if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, meaning that these angles are either congruent or these angles are congruent. Pause video. start over on Theorem 819. Okay. Theorem 819 says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And now if you look at this shape, only one pair of opposite angles can be congruent. I'm going to tell you that it's this angle and this angle, which makes sense because if I look at the other two opposite angles, talking about this angle and this angle, you can see that one of them is greater than the other one. And if you can't see that, we can simply redraw those as triangles. And you can see that one of them is more acute than the other, meaning it's less than 90. So the properties of a kite that we're given so far is not only are the diagonals perpendicular, but opposite angles are congruent. Now if you look at this shape, when you draw the diagonals in here, you have two triangles. Okay? But then, because you have perpendicular diagonals, watch this. You have you have two congruent triangles. Remember, this angle and this angle are congruent. This side and this side are congruent. This side and this side are congruent, which means that you have two triangles that are congruent by side angle side congruency. Remember that when you're solving those for the different pieces. If we go to the next page, here we're not only told to solve for missing pieces of trapezoids, but also for missing pieces of a kite. What I would like you to do is I would like you to practice on these four problems. In fact, you know what? For the sake of time, let's practice number 1 and number 2. Okay? And the reason I would like you to do that is number 1 deals with angles again. Number 2 deals with the kite. And if you would like to practice the mid-segment theorem, you can look at number 3 and 4. Go ahead and pause the video, work on these two problems right now, and then you can either fast forward to look at the homework or you can watch me as I solve number 3 and 4. But pause the video and work on those right now. Okay, let's look at number 1 first. You can see that I've already got the diagram filled out for angle B, or angle A, angle B, and angle C. Let me tell you where I started. I started by saying if the top two, or the top and the bottom, are parallel, then I have consecutive interior angles, and consecutive interior angles should be supplementary. So 180 minus 63 should give me angle A, which is 117. I then looked at the isosceles part of the trapezoid and said, if these two sides are congruent, then the base angles are congruent, which means if this angle is 63, then angle C is 63. I then knew that angle C and angle B had to be supplementary because of consecutive interior angles, so I said 180 minus 63 is 117. Number 2 was a little bit harder. Number 2 deals with the properties of a kite. Now, what I'm going to do is I'm going to draw a diagonal in this problem so that you can see my thought process. I knew that angle T was 32 degrees. It tells me that, says that this angle is 32 degrees. But when I draw a diagonal, I cut my kite into 2 halves, 2 equal parts, meaning that this angle T and angle K got bisected. So, this half of angle T is 16 and this half is 16. You might say, how did I get that? If angle T as a whole, let me highlight it so you can see. If this entire angle is 32, when it got bisected, it got cut into 2 equal halves. So I merely divided 32 into half and got 16 each. Well, then I thought, if I have a triangle that looks like this, okay, and if this angle is 124 and this angle is 16, then this angle has to get me from 124 plus 16 to 180 because it's a triangle. So I solved that and got 40, which is why I wrote this. The only problem is this is not completely accurate. And the reason it isn't is because of this. Let me show you. Angle K is actually right here. So I found that this half is 40, but what does that mean that the whole angle is? It means that it's 2 times 40 because we have two angles that are equal in here, which means 2 times 40 is 80. There's another way you could have done this, and it's actually drawing from back in chapter 2 or 3 where we deal with quadrilaterals and properties of different shapes. The moment I have something with 4 sides, I can find out that because it has 4 sides, I can find out the total interior angle measure with the formula n minus 2 times 180. A 4-sided object minus 2 times 180 tells me that the interior of the shape should equal 360 degrees. They already told me that this angle is 124 and this angle is 32. The property of a kite tells me that this angle and this angle are congruent, which means that this angle is 124. So I could have said 360 equals this angle plus 124 plus 32 plus 124. Then when I subtract or add all these up and then subtract, I'm going to get this angle equals 80 degrees. A couple different ways you could have solved that. Now let's look down at number 3 and number 4 very quickly. Number 3 and number 4 deal with the mid-segment, where the mid-segment is 1/2 the distance of the top and bottom added together. So I wrote this little geometry expression. RT, my mid-segment, is 1/2 of the top, WX, plus the bottom, ZY. Well, then I substituted in WX is 7 and ZY is 13. When I add those two together, I get 20, which means RT is 1/2 of 20. RT is 10. Not too hard. I want you to look at number 4, though, because number 4 is very, very involved. I'm going to solve it right here. I still set it up to say the mid-segment, 12, equals 1/2 the top times the bottom, or plus the bottom, excuse me. This one's a little bit harder simply because it's not as straightforward. You can't add 16 and 4x, but you can do the distributive property. 1/2 times 16 plus 1/2 times 4x equals 12. Subtract 8. Divide by 2. I find 2, or I find that x equals 2. That one's a little bit tougher. We set up the same idea, though, to start our problem off. So, find the value of x equals 2. Hopefully this makes a lot of sense, and this actually concludes our chapter on quadrilaterals. Let's take a look at your homework now.